Torque problem number 7. Find the forces A and B, and this bar weighs 150 newtons. So this is the bar. So here we have a bar. And there is 1, 2, 3, 4 forces acting on this bar, plus its own weight, which is 150 newtons. So because this bar is uniform, we are going to place the weight in the middle of the bar, straight down. And this is 150 newton. So we are going to apply the torque equation to find those two forces, A and B. So first, place a fulcrum on A to find B. So temporarily we are going to place a fulcrum represented by this triangle right here on A. By doing that, this force A will not produce any torque because a force acting on a fulcrum does not produce torque. Now we are going to identify the forces that produce clockwise or counterclockwise torque. So 200 is clockwise, 150 is clockwise, B is counterclockwise, and 100 is clockwise. Now we are going to group them using the torque equation. So the sum of all clockwise torque is equal to the sum of all counterclockwise torque. So for clockwise, we have 200, we have 150, and we have 100. So we are going to group those three forces on this side of this equation following the torque formula. So torque is the force applied times the distance between the force and the fulcrum. So we are going to start with 200. So 200 times the distance where the force is applied to the fulcrum is 2, plus the next is 150. The distance to the fulcrum is, well, if the bar is 8 plus 6 is 14, and the weight is right in the middle, so there will be 7. So there will be at 7 meters from the fulcrum, so 7. Plus 100, and the distance where the force is applied to the fulcrum, which is 10 plus 2, 12, times 12. Now counterclockwise, we have B. So it will be B times the distance where the force is applied to the fulcrum, which is 8. So now we are going to multiply all these portions. So there will be 400 plus 150 times 7 plus 100 times 12 is equal 2,650 divided by 8. All right, so let me do a little bit slower here. 2,650 equal to 8b. So by dividing both terms by 8, so B is 331.25 newtons. So we found one force. Now, second, to find B, we are going to place a fulcrum to find A. You are going to place a fulcrum on B to find A. So now we have to erase this fulcrum. We have to erase the clockwise and counterclockwise because everything is going to change. Okay. Now we are going to place the fulcrum on B to find A. So now we need to identify the forces that produce clockwise and counterclockwise torque. So A produce clockwise, 200 counterclockwise, 150 counterclockwise, and 100 will be clockwise. So now we are going to use torque equation again, equilibrium, so they are equal. Okay, so for clockwise we have A times the distance to the fulcrum, which is 8, plus another one that is clockwise is 100 times the distance to the fulcrum. This here we need to think a little bit. The whole bar is 14 and here is 12, so that means this section is 2 meters. Okay, so if this is 6 and this is 2, so the distance between this force and the fulcrum should be 4. So that is the distance that you are going to apply here. So that's equal to counterclockwise, we have 200 times the distance to the fulcrum. One more time, you need to think a little bit. So we know from here to here is 8, and this portion is 2, therefore this is 6. So 200 times 6 plus 150 and the distance to the fulcrum. So we know that this vector is placed at 7 and the distance from here to here is 8. So this portion is 1 meter. So that will be 150 times the distance where this force is applied to the fulcrum, which is 1. So then you are going to multiply, 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 and you should have 8A is equal to 1,200 plus 150 minus 400. So A is, after you solve this side, you divide by 8. So your answer is 118.75 newtons. To check if your answer is correct, because you assume the system in equilibrium, you can state that the sum of forces up is equal to the sum of forces down. So the forces up, I have A and B. So when you add A plus B, you have 450. That is up, right? Now, the forces down, we have 200. Down we have 200. You have 100. And you have 150. So when you add all those numbers, you have 450 as well. So the system in equilibrium. And your answers are correct.